vernal equinox. Okay? Now, when it goes from north to south, it's around September 23rd every year. This is called the autumnal equinox, aptly named autumn. Autumn is coming. Okay? Now, for today's discussion, we are concerned primarily with, well, wholly with the vernal equinox. As it relates to the ages, the vernal equinox is the one that's important. Okay? We have other celestial events like the winter solstice and summer solstice, stuff like that take place. Thank you for reminding me. We have other events like the winter solstice, summer solstice, like that take place. We're dealing simply with the equinoxes. Okay? And now the vernal equinox. So, one more interesting fact is the fact that although my drawing is not to scale, you'll notice those on the DVD, it's not here on the board, but there's a little line here that says 23.5 degrees. And it's got a little curvature. What that is that's how off the ecliptic orbit is off of the celestial equator. Okay, that's how far off. It's only 23.5 degrees off of the celestial equator. So it's actually a lot closer than it appears in that picture. Okay, the picture of the ecliptic orbit should actually be leaned a whole lot to the right to be more to scale. You understand what I'm saying?
Yeah.
Okay.
It should be more tilted.
Right. Now, we also have the fact that the Earth is tilted on its axis. Okay? Now remember, the sun is stationary. So the sun is always going to travel the same path. But since the Earth wobbles on its axis, you can imagine the number of variations that occur. As this Earth is, as this sun is apparently, it looks to be, traveling around the Earth. If the Earth is wobbling, if you go out and you make an observation one day, on June 1st, 1979, you go out and make an observation, and you calculate the days precisely. You don't use the Gregorian calendar, you say 30 days, or rather 28 days in every month. So if you get a Gregorian, we're going to go 28 days in every month. And you go 10 years. It's now 1989. You go out June 1st. After 10 years, you will not see the sun in the same place you saw it 10 years ago on that June 1st. You understand what I'm saying?
Mm-hmm.
Why? Because there's so many variations that's created. But I don't get into the particulars, but there's so many variations that's created by the wobble of the Earth. Okay?
Question.
Yes.
Is the Earth apparently wobbling?
No, the Earth is actually wobbling.
Oh.
The Earth is actually wobbling. So on this axis, it's tilted, and then it does. It's more like a spinning top. It does like a cone shape. If this is the Earth's axis, those watching on video, excuse me for a moment. If this is the Earth, okay, this is its axis. First off, it's tilted. Axis will be the middle of it. Like my spinal cord is the middle of me. So the axis of the Earth, right? It's tilted. And then it does sort of like a circular thing. From the axis, it follows this path around. You see? It follows that circle. So it's like a spinning top. It just goes like that. Like a cone or a spinning top. You understand?
Yeah. Right.
On this axis. If you take, have you ever spun a top?
Yeah.
If you notice, the top doesn't stay, as it's spinning, it doesn't stay stationary.
Like one of those little tops you just...
Yeah, a spinning top. It wobbles. You know how it wobbles? And as it slows down, you can see the cone-shaped wobble even more.
Mm-hmm.
That's what the Earth is doing. So on its axis, it's tilted, and then it's wobbling in a cone shape.
So it's not spinning, it's just wobbling?
It's also spinning.
Spinning. While it's spinning, it's wobbling.
The same way you have a spinning top. You spin that spinning top. It's spinning really fast,
But it's still wobbling.
but it still leans this way. And then as it's spinning, then it leans that way. You see what I'm saying?
Yeah.
That's what the earth is doing. It's spinning, but it's leaning. And so, you know, in the top, in the little part that you grip from the spinning top, that part, if you could put it perfectly on some kind of surface where it could draw, it would draw a circle as it's spinning. That little point that comes out of the top, it would draw a circle as it's spinning. Say if we spun a top in this room and then when we brought the ceiling down, or say if we put a spray can in it and we spun it, it would draw a circle on the roof, on the ceiling of this room.
Right.
If we took a big top and we spun it,
So it never leaves that circle though?
it stays on its axis and it wobbles
And it's
and it stays in space, which is another phenomenon that we're not going to discuss today.
Okay.
Okay?
Because that's what was confusing. Like, I understood all of that, but I was like, it does all this wobbling and don't move.
It has an axis. This is the axis.
Yeah, I know. I
This is the
understand.
middle point
Right.
where it stays. It
Right.
tilts off of it
Mhm.
and then it wobbles, and that's what it does.
It don't move from that.
It
wobble.
doesn't move from that. Well, actually, yeah, it does. It travels around the sun.
Oh, yeah.
On its axis.
So it's spinning and wobbling and traveling around.
It's
Yes.
not like going all over the place.
Yes,
and stuff. It's
exactly.
got
Exercise.
But everything is action.
That's because of the sun. I mean, I understand why, like, it doesn't move from its spot where it's wobbling and spinning because
On
it's
its
sun gravity that's holding it.
Right, but
there.
it does float around the
Like
sun.
it goes around the sun, like our moon
Mhm.
goes around the earth, pretty much.
Not exactly.
Okay,
But we're going to deal with
Well, but
just the fact that the earth, look at the variations. You have the 23.5 degree tilt, which is not important. We're not dealing with, you don't have to memorize 23.5 degrees. But you have 23.5 degree tilt. Then you have the spinning, and then you have the wobble motion that takes place. And then you have the earth going all the way around the sun. Okay? So this creates a whole bunch of variations to what you can see at any date and time in the night sky. Okay? Now, by all of these variations, now I could have spent a whole lot of time dealing with particulars, but again, we're talking about just the variations. The fact that the equator exists, the fact that it's tilted this way, and the fact that it goes in the cone shape. There's so many variations to the Earth's movements. So what all those variations created is something that's called, our next vocabulary word, the precession of the equinoxes. Okay? The precession of the equinoxes is your next vocabulary word.
is it procession or pre?
P-R-O. Procession.
Procession.
Yep. Precession of the equinoxes. And we've gotten a little bit off of the official LIU statements, but I'll say this to the students who have our student handbook. You can look at the official LIU statement regarding these issues if I haven't been totally clear in the class. And for those that don't have the student handbook, go purchase it. And you'll get the official LIU statements. So we're at the precession of the equinoxes here. Okay? Now again, we're dealing with the way that things appear. We're not getting into the real particulars of it. But again, that variation, remember, because you're going to ask yourself, what causes the precession of equinoxes to take place? You're going to want to ask yourself that once we get into the precession. Remember, it's the variation of all those different ways that the earth is moving that creates the precession of the equinoxes, okay? Okay, now,